Hello and welcome back to another video. In this video, we'll focus on compiling and building the ArduPlane firmware. This is a continuation of our series on customizing the ArduPlane firmware. In our previous video, we looked at how to fork and set up the codebase, so if you haven't had a chance to watch this, please do so as we're going to build on some of those concepts covered in that video. A URL to that tutorial is in this video's description below. Now, before we get started, I wanted to make a quick note that while the example we use in this series of tutorials focuses on the ArduPlane portion of the ArduPilot codebase, the concepts should transfer to ArduCopter, ArduRover, and other firmware families. Now, before we dive into the compilation process, let's take a moment to look at the overall architecture and workflow of the build process. So in the previous video, we saw how to find the ArduPilot codebase on GitHub and then fork this to our personal account. Now, all of this was occurring in the cloud, so we then looked at how to get this onto our local developer machine by cloning the repository. Now, we did this so that we could utilize Windows tools such as Visual Studio to edit and navigate the code in a native Windows 10 environment. Now, while we can edit and navigate the code in the native Windows 10 environment, we actually want to build and compile the code within a Linux environment. So at this point, one option is to go out and find yourself a separate computer running Linux, but an easier solution is to simply use the Windows Subsystem for Linux on this same local machine. If you haven't done so already, please watch my video covering the installation and usage of the Windows Subsystem for Linux. The URL to that tutorial is also in this video's description below. Now, within the Linux environment, we can actually clone this same repository and use Linux tools to build and compile the code base. So, the workflow that makes sense within this infrastructure is then to use the Windows environment to edit and modify the code, and then push it up to our forked remote repository on GitHub. We'll then pull these changes down from the remote repository to the Linux version and then build/compile the code within Linux. So this video actually outlines many of the steps that are covered in the ArduPilot document entitled Setting Up the Waf Build Environment on Windows 10 using WSL. And I think I spelled that pretty horribly, but I'm sure Google will be able to figure it out here. Yep, it's the first hit. Again, I will include a URL to this document in the video's description below, or you can simply find it by searching like I did. Hopefully you'll spell it a little bit better, but you'll see that this has a lot of the steps that we'll be talking about today here, and it might be helpful to have this document up for reference as you follow along with the video. Alright, so to get started, let's go ahead and launch Linux Bash. There's a couple ways to do this. Again, we can go ahead and hit the Start menu in Windows 10 and just search for Bash here. And here, if we click on this, we'll see we get a Bash terminal. The other way we could do this is, again, let's come to the Start menu here and just search for Ubuntu, and here it is. And again, by clicking on this, we also get a Bash terminal here. So both of them should be equivalent, so why don't we just keep this one here on the right open. I'll go ahead and close this. Now, just recall now that although we launched the Bash terminal from the Windows Start menu, we're actually now within the Windows Subsystem for Linux. So any work that we do within the Bash terminal is in the Linux environment. So we should almost think of ourselves as sitting at a separate Linux machine at this point. Alright, so let's see where we are right now in the terminal. So I'll just print the working directory. We're in home/lum. So let's go to the top level directory, and I can get there by doing cd ... twice. Let's take a look at what folders and files are in the current top level directory. Here's what it looks like. Again, I know that I'm in the top level directory because if I try to cd ... and go up a level, we see that we didn't actually go anywhere. So great, we're in the top level directory right now. And what we want to do next is things like install some packages and execute other operations that are actually going to require elevated privileges and permissions. So for example, right now if we try to go into this root folder here, if I try to say cd root, we see that permissions are denied here because we're actually just logged in as a normal user. So to do this type of operation, we actually need to change to the root user. Now, if you've been following along with this series of videos, you might remember that we set a password for our normal user back when we installed the Windows Subsystem for Linux, but we didn't actually set the password for the root user, so let's do that now. So in order to do that, let's first clear the terminal so I get a nice clear terminal. And I'm now going to type in just sudo passwd root. So it's going to ask me for the password for my normal user right now, so the user that I'm currently logged in with. So let's go ahead and enter that right now. And now I'm going to enter the new password I want for the root user. And I'm going to retype it. And the password was successfully updated. So now what I can do is I've entered the password for the root user. Let's go ahead and take over root control of this terminal. So I'm going to switch to the root user or the super user by typing su root. And I'm going to have to type in that password we just created. And now you see that instead of being lum, I am now the root user here. So if I go ahead and let's take a look at where we are. Again, we're still on this top level. I should now be able to go into that root folder. There we are. We're in the root folder. So you see that we are now currently a super user here, and we should be able to now take some next steps. So I'll go and clear the terminal so we have something nice and clean to start with for the next operation. All right, so let's go ahead and navigate to the top level again. Great. And what we want to do now that we're logged in as the root is let's get some packages. So first, let's go ahead and get Python. So I'm going to type in sudo apt get install python -pip. And this is going to download some necessary Python packages, and you may have to hit yes to continue through many of these. There might be a couple of these prompts, so to keep this from being too boring, I'm going to go ahead and pause the video and continue hitting yes, and I'll come back when I'm finished installing all these packages. Alright, great, and we're back, and it looks like Python has installed successfully, so I've gone ahead and cleared the terminal so we can start fresh. Let's do the same thing and try to install Get. So I'm going to go ahead and type sudo apt get install Git. Now, depending on your machine, this may or may not already be done for you. So, for example, here we see that this package actually was already installed. So, I don't actually need to do anything. So, again, let's go ahead and clear the terminal, and we should be ready to move on. Okay, great. So the next thing we're going to want to do here is first check to make sure we're in the top level directory. And great, we are. And since we have root access, we should be able to go ahead and change directories to the root folder. And now within this folder, we are going to want to make a directory where we're going to hold all of our GitHub repositories. So let's just make a directory called maybe, how about GitHub? Okay. And we see there's a GitHub folder. So let's go ahead and enter that GitHub folder that we just created. And now what we can do here is let's go ahead and find the URL of the repository we want to clone. So I'm going to go ahead and start up GitHub. And if you remember from our last video here, what we ended up doing was we forked the ArduPilot repository to our own private version of this. So in this case, it's under my clum demo /ArduPilot. So here's a repository, so let's go ahead and just find the URL of this. So I will go ahead and click on the clone or download button, and then I will copy this URL to my notepad. Let's go ahead and minimize this. And now coming back to bash here, let's just go ahead and do a git clone, and then paste in the URL that we just collected here. Alright, so let's go ahead and clone that. And again, what we're doing right now is cloning or downloading the ArduPilot codebase, our forked version of it, to our Linux environment. So this might take a little while, so I'll go ahead and pause the video and we'll come back when this is completed. Alright, and we're back, and it looks like that completed. So let's go ahead and clear the screen to get a nice terminal here. And now if we take a look here at the file structure, we see that, yep, we got that ArduPilot repository cloned to our machine. So again, if you're kind of new to the Linux environment and would like to see this in Windows as well, we can also go ahead and start up a Windows Explorer here. And if you remember, we said that what we could do here is basically find that directory, which I believe was here under, remember, C, users, your username, app data, local, packages, I believe. Where is it? Yep, here we go. Packages. Here's our Ubuntu, and then we want, I believe, it was local state here, root TFS. And here we go, and again, let's now find inside the root folder, we created the GitHub folder, and there we are. There's the ArduPilot repository that we just cloned down. So we see it both here in Windows, which again, we want to make sure we do not make any modifications to any of these files using Windows software. And here it is in the Linux environment where we can modify this. So, tell you what, let's actually change directory into this ArduPilot folder. And I'll do it over here as well, and you can kind of see the parallels. So let's just go ahead and take a look. And yep, this is what we're looking for. So at this point, what we next want to do here is we actually want to come in here to this tools folder, and we're going to run a script here that's going to help us install a few prerequisites. Okay, so what we're looking for here is a script that's located in the tools/scripts folder. So let's change directory here in Linux, and over here in Windows we can do the same thing. We can go ahead and go into the tools folder, then come here to scripts, and what we're looking for here is this script right here, install prereqs ubuntu.sh. And again, we want to execute this in the Linux environment here. So let's just go ahead and make sure that we find it here in this folder. And where is it? Install prerequisites ubuntu.sh. It's right there. Great. So to execute this, or to actually get this to run here, all we're going to need to do here is, now we're in the folder, so let's just go ahead and /install prereqs ubuntu.sh. And let's execute this, and we're going to see that this is going to download a bunch of prerequisites and packages. You may need to monitor this periodically and hit yes to any prompts that come back. So this might take a little while, so again, why don't we go ahead and pause the video, and we'll come back after I've done, for example, here's one of these prompts here, so let's go ahead and hit yes here, let that keep going. You may have to do this a few other times, so I'll pause the video and come back once this has completed. Okay, it looks like the install prereqs ubuntu.sh script has completed execution. There were a few sections where I had to manually say yes to allow the install to proceed, but pretty much everything went fairly smoothly, and it took approximately 30 minutes on my machine. So why don't we go ahead and navigate back to the top level of this repository, which was the ArduPilot folder in this case here. And also, let's go ahead and clear the terminal of all these commands so we get something nice to look at. Okay, and the next thing the documentation wants us to do is remove a very specific directory here. And this directory is actually located at the top level of the Linux file structure here. So let's go up to the root level here, which was right here. So you see this is the root level of my Linux file directory here. And there's this folder that we're asked to remove that's here in OPT, this GCC ARM none AAB with this date here and the bin. So I guess what we want to do is remove actually this entire folder here. So what we can do here is let's go ahead and type in bash sudo rm-rf here, which is a recursive delete here, and then type in the absolute file path of this. So I'm going to start here with the / to say that this is starting with respect to the top level of my Linux directory, and again that's opt/gcc. I'll tab complete to get that entire thing, and then I'll type in bin. There we go. So when I execute this, this should hopefully delete this folder right here. I'm a little paranoid here because, like we said, we don't want to have Windows interfering with Linux. So tell you what, let me close the Windows Explorer here before I execute the command, and then I'll reopen it here to the same location, and hopefully we should see this bin folder be deleted. So I'll close this now. Alright, so let's go ahead and execute this remove command here, and that is complete, so it should have deleted. So again, just to double check, let's go ahead and start up Windows Explorer here. I've got a quick access link here to that long file path for where the Windows Subsystem for Linux is stored here. And again, let's go ahead and check in OPT this, and yes, as expected, that binary folder is gone. Great, so let's go ahead and close Windows again. And why don't we go ahead and clear the terminal here so we get something clean to take our next step, where we're going to install some extra tools so we can compile for various targets. Okay, so what we need to do now is install a bunch of extra tools here, and the series of commands are actually well listed here in the documentation that we're running through. So they're all listed right here. As you can see, they're adding a whole bunch of different extra tools here and updating and upgrading all of the packages. So why don't I go ahead and let's walk through these one at a time here. So starting with the first one, let's just go ahead and sudo add-apt-repository ppa:/George Edison 55/cmake-3.x -y. All right, let's go ahead and enter that here. And again, all I'm going to be doing is entering all of those commands in the documentation one at a time here, and this may take a little while, so why don't I go ahead and pause the video, and I will come back once I've done all of those. So for reference, the series of commands that are needed are shown here. We just executed the first line, and rather than watching me enter in all the subsequent commands, we're going to skip the screen capture demonstration of them and instead just fast forward until just after the last command of sudo apt-get upgrade. If you'd like, you may want to pause the video here so you can enter in the commands yourself and then restart the video after you've executed the last command. Okay, so the upgrade completed successfully, so let's go ahead and clear the terminal here to get a nice blank slate to start with. Again, we're in the ArduPilot directory. Let's take a look at the Git status here just to make sure we're up to date, because the next thing we're going to want to do is actually try to check out the branch that we want to build here. So this should hopefully come back saying that our branch is up to date. And if it does, we're going to go ahead and, yep, it did. Let's take a look at which branch we're on. We should be on the master branch. You know what, for completeness, let's take a look at all of the branches that are available in this repository. And as expected, we see that this is our forked version of the ArduPilot code, which has our AA441 v380 branch that we created in the previous video. But for now, let's just stay on master and assume that it's in a buildable state. So again, let me clear the terminal here. So what I want to do now is let's take a look at all of the list of supported boards that Waf can use to build with. So Waf is the preferred build tool for ArduPilot, and it works well within Bash. So what I can do here is I can just say /waf list_boards. And this is going to be all of the boards that we can build for here. And there have been some reports saying that Waf may need to configure itself the first time you run this command. So if you end up with an error when you try to list the boards, just go ahead and run the command again. So the configuration that we're using is this one right here. It's the PX4-V2. So let's configure for this board by simply typing in /waf configure --board PX4-V2. And give this a second to complete here. And the configuration was successful. So what we can now do, since we've configured the board, is just go ahead and ask Waf to compile for Plane or Copter or whichever firmware set we want to use. Since we want to do ArduPlane, let's just say /waf plane. Hit enter, and we're off on the build process. Now, this may take a little while here, especially your first time compiling the software. So again, I'm going to go ahead and pause the video, and we'll come back when this is completed. Okay, so we seem to have run into an error during the compilation process in this uavcangen.py file. Now, this is going to sound odd, but it's been observed to work the second time it's executed, so let's just try to run /waf plane again and see if we get the same error. Great, and it looks like the compilation was successful, so why don't we go ahead and take a look at the file that was compiled and created. So that's actually located here within the ArduPilot repository. Let's go to build /px4v2/bin. And if we take a look in here, there it is. We see there's a file ArduPlane.px4, and that was the one that was just created. So we might want to find this also in the Windows Explorer application. So again, let's just go ahead and start up Windows Explorer here. I will navigate to the root of my Linux subsystem for Windows. And let's go ahead and go into, again, root, GitHub, and here's the ArduPilot repository. So I'll go into this. So I'm now into the repository. So again, that file should be located within build, px4v2, bin, and here it is, the ArduPlane.px4v2, and we see, yes, it was just created a few minutes ago. So what I might want to do, since I have this in Windows, again, we remember that we don't want to actually modify any of these files here, but it's perfectly fine to go ahead and copy this now and move it to somewhere on Windows where I'll be able to use it later. So I'm going to start Windows Explorer here. I just have a temporary folder that I store on my desktop. Let's go ahead and paste it here. And now that it's in the Windows environment, I should have no problem modifying this. I don't have to worry about metadata corruption or anything like that. So let's just change the name of this to ArduPlane, how about latest here. So again, this is to note this is the version that we just built that was the latest version of ArduPlane based on the code that we had forked. So let's go ahead and close all these. And I'm going to go ahead and go up a few levels to the top level of the repository, which should be right here. And we'll clear the terminal so we have something clean to work with. And what we want to do now is we've built successfully the latest version of the ArduPlane firmware. Now what we may want to do is actually switch back to that branch we created earlier, which is the version 3.8.0, and verify that we can build that. So let's go and do that now. Okay, so to switch branches, let's first take a look at that branch to make sure we can see it on the remote. So again, let's go and do, I think we did this earlier, git branch dash A, and we'll look for all the branches here, and yep, here it is on the remote repository. It's our AA441_V380 branch that we want. So what I'm going to first do here is let's just go and try to switch to this. So if I type git checkout, and the branch we want is AA441_V_3_8_0. Let's go ahead and check out that branch now. And it might take a few seconds here to switch the files. And there we are. So we should now be on that branch. If I go double check and say git branch, yep, we see we are now on the AA441V380 branch. We can double check to make sure all those files are there. If you remember correctly, what we ended up doing here is we added that Visual Studio solution to this branch to edit our files. Now, while we're not going to use it here in the Linux environment, we can just verify that it exists to make sure we switched branches properly. So let's just go and take a look here. And yep, here we are, ArduPilot AA441.sln. It's sitting there, so we've gone ahead and switched branches successfully. So let's go ahead and clear the terminal, and the next thing we want to do now that we've switched the branches, let's just go again and recompile the code on this branch here. Alright, so to go ahead and compile, we can just simply go ahead and /waf, and we'll type in plane again to compile for plane. The board should already be configured for the px4-v2. We're just going to recompile with the new set of code here, which again should be the 3.8.0 version of ArduPlane. So again, let's give this a couple of minutes to complete the compilation, and we'll come back when it completes. Okay, so unfortunately we ran into a slight error here during the compilation process. So what we may need to try here is cleaning the build here. So let's go /waf here, and I'll say distclean for to clean this. So let's go ahead and run this command here to clean up the build here, and once this completes, we will try to compile again. So I'll pause the video and come back once this clean operation is done. Okay, so the clean completed, so let's go ahead and, just to be safe, let's go ahead and configure the board again. And now that we've completed configuring the board, let's try to build now with the clean build files. So again, this might take a little while, so I'm going to go ahead and pause the video, and hopefully we'll come back with a successful compilation this time. Okay, we ran into another error, so another thing that we can try here is to update some of the submodules. So to do that, we're going to say git submodule update -init -recursive. So let's run this and see if this will help. So again, I'm going to go ahead and pause the video and we'll come back once this completes. Okay, that was actually faster than I expected, so let's just go ahead and, again, let's clean out the intermediate build files here. And once this finishes, we'll probably go and want to configure the board again and then build the plane. So again, perfect, that finished cleaning, so let's go ahead and configure the board. And let's go ahead and try to compile again. Okay, so hopefully this will work this time. Again, I'm going to go ahead and pause the video while we wait for this compilation to complete, and we'll be back in a second. Alright, and we're back, and it looked like that did the trick here. So we now have successfully compiled the firmware, so let's once again go and find that firmware here in root, GitHub, the name of my repository, inside build, px4v2, bin. Yep, and there we are, the file that was just created a few minutes ago. So again, what we're going to want to do is let's copy this and paste it here into my temporary folder on the desktop next to the old one that we made. And again, let's maybe rename this file now. This should be our customized version 3.8.0 version of the firmware. And what we're going to want to look at shortly is loading these two onto an actual Pixhawk to see the differences. So with that, I think we have successfully built the ArduPlane firmware. So let's go ahead and take a moment to summarize what we've accomplished in this video. So in this video, we looked at how to set up your build environment and actually compile the ArduPilot firmware. Now, for subsequent builds, you obviously don't need to go through all of these steps that we just covered. In fact, subsequent builds on your machine should be fairly quick. And here's a list of the relevant actions and commands that you'll need for future builds. So you see, the first thing you need to do is obviously just launch bash from Windows 10. Once you're in bash, just go ahead and take over root control of the terminal using su root and then entering your password. Then all you need to do is navigate into the ArduPilot repository, which is probably somewhere in the root folder. Once you're in the ArduPilot repository, just go ahead and pull changes from the remote repository using a git pull origin and then the name of your branch. And then all you need to do is actually just compile the code using a ./waf plane. Finally, we saw that you might run into an error or two during the compilation process, and below here are two things to try if you're troubleshooting your build process. So, with that, I hope you enjoyed this video. We'll continue our discussion on modifying the ArduPilot codebase in a future video, and I hope to see you then. Thanks for watching.